Assalamu alaikum, and our next topic is Stefans Law. Okay, it's quite easy. I'll show you what's Stefans Law. Up to or above this, make revise, make revision in your mind what I taught before. There is one body, we are heating it, it should absorb. Okay, when it absorbs, it will emit also. Do you know that? I'll tell you. Stefans Law. I should change the pen. Or is black? When I say I will heat it. For example, this is an iron piece. I am heating it from the bottom. Okay, it's absorbing the energy. Okay, it have what are the properties? Just look at here. Okay, a little concentration required. It have surface area. Okay, that's it. It has surface area. Once it get absorb the energy, it is not perfectly black that it will absorb only. It can emit the energy also. Okay, if I make if I heat the iron piece, I put in front of you, how you will feel? You will feel little hot. If you take your hand near that, you will feel the hotness. Okay, you will feel the temperature. What it means? It means that it is giving out the energy which it have absorbed already. So this it will emit the energy. Okay, so what Stefan say? Stefan says that the amount of energy emitted per unit area in unit time is always proportional to the fourth power of absolute temperature. I will write it and I will explain it. Energy emitted we will represent by Q, area A, time T, proportional to fourth power of absolute temperature. Okay, now for example, this is that iron piece which is giving the energy, it's emitting the energy. Okay, how much it's emitting? It's emitting the energy per unit area per unit time. Emitting, I am feeling it. Okay, how it is proportional to the fourth power of temperature? You forget about the fourth power. Just if you can understand the temperature, you can understand fourth power also. If I say it is proportional to the temperature, okay, for example, it's giving the energy. How much it's giving energy? How much it is hot? Whatever its temperature. Is there any direct proportion? Yes. Okay, again after 1 hour I see how much it's giving energy. Little, according to its temperature. I don't know, you can check its temperature also. If it is cool, it's giving that energy. If it's hot, it's giving a much energy. That's why there is a direct proportion between amount of energy which is emitting and whatever its temperature, absolute temperature of the body. Did you understand? Okay, so now if I make the reading after some time, there is relation like that between observed values, that the temperature values always having the fourth power. Okay, so it's done. It is already scientifically proved. It's said, Stefan said that. Okay, he observed that, then he put the law. Okay, so amount of energy emitted per unit area per unit time is directly proportional to the fourth power of absolute temperature. Understand? Okay, now if I say what is this? Only this ratio. You may have studied this before. Yes. What's this? This is emissive power. Okay, So we know one more thing, emissive power is always equal to sorry, one thing I am remaining here. If I remove the constant, what will come? Equal to with some constant, that sigma is constant. Okay, q by at is equal to sigma into constant. What is this sigma? It is Stefans constant. What it is? I'll write here. It is Stefans constant having value 5, 6, 7, 8. I mean it's easy. 5.67 into 10 power minus 8. You can remember it like that, 5, 6, 7, 8. Okay, so Stephen's constant is 5.67 into 10 power minus 8. That is the value. Okay, now we move towards the derivation. Okay, what's this? I make you remember, it is emissive power of a black body. Okay, so here I write emissive power of a black body is equal to q by at. Okay, so what's the emissive power of a normal body, ordinary body? So that E simple is equal to q by at into E, where E is the coefficient of emission. Why not E is here? E is not here because it have the value 1. Okay, so q by at I can write like this, E is equal to EB into E. Simple. You understand up to here? I can make it equation 1. Okay, so where I was, yeah, I can use this value here. Okay, I can write from here that we know Stefans law that q by at is equal to sigma into t power 4. Okay, what is it here? Emissive power of a black body, that is equal to sigma into t power 4. According to equation 1, if we use it, we know that E is equal to EB into E. That's why EB will be equal to E into, sorry, EB will be equal to capital E by small e. Okay, can I put this value here? So using equation 1, I can say E by E is equal to sigma into t power 4. That's why only E is equal to sigma into E into t power 4. In this way we can modify the Stefans law. Otherwise this is only the Stefans law. Okay, but this ratio is emissive power of a black body. Always we will not talk about the black body, we want ordinary body also. That's why we can make like this. Okay, now if I say that there is a difference in temperature, so I can write like this, E is equal to sigma into E into t power 4 of a absolute temperature minus t naught power 4. What is t naught power 4? T naught power 4 is the temperature, outside temperature of the surrounding. T naught power 4 is the temperature of the surrounding. Okay, so here, did you understand why we are learning this also? Because the numerical can come. Okay, so like that I explained Stefans law. So that's it, and we will meet again inshallah tomorrow. Okay, so write, and you will write, you can take the screenshot also, then you can write. And I would like to say one more thing. I have 1 minute only. Look, here is E. It is for the black body. Okay, T power 4 minus T naught power 4. T power 4 yani temperature, absolute temperature of the body. T naught power 4 is the surrounding temperature. Okay, you can remember like that. Up to here you should write. Okay, so that's it, and we will meet again. Keep requesting me, I will help you inshallah. So that's it. Assalamu alaikum.